I'm Dr. Celeste Fall, and I'll be talking a little bit more about the alcohol metabolism as related to the blood alcohol curve, and then we'll look at one or two examples to follow. Now, this is very important, as we know in an intoxicated driver that was arrested, not just the signs and symptoms at the time of arrest, but also the blood alcohol concentration is very important. So how do we actually understand blood alcohol concentration? And to help us with this, I'm going to employ the blood alcohol curve. If we look at the blood alcohol curve, we'll see that it's got different aspects to it. We'll first draw the axes. On this axis is the blood alcohol concentration, and we're going to look at, we'll just say it's grams per 100 moles. On this axis, we've got the time in hours. And if we look at the rising limb first, this is represented when the alcohol that's absorbed, the rate of alcohol absorption, is higher than that is eliminated. So you're sitting with a gradient like this. Now this gradient varies depending on the amount of alcohol and type of alcohol that's consumed. So for example, if you take a shot of brandy in a very short time period, this gradient is obviously going to be slightly more acute. Whereas if you're a social drinker, maybe drinking a glass of wine over a longer period of time, this gradient will be more gradual. So we looked at the rising limb of a blood alcohol curve. Let's now look at the peak of a blood alcohol curve. The peak of a blood alcohol curve is that area on the curve where the concentration or the rate of absorption is equal to the elimination of the alcohol. And this peak, or the height of a peak, so to say, is dependent on the amount of alcohol that's consumed. So if it's one drink, obviously at this stage when the peak is reached, usually at about 15 to 90 minutes, depending on the type and the volume of alcohol and the percentage of alcohol, this curve will start to dip, and we'll talk about the descending limb just now. But if at any time point another drink is consumed, say for example a second alcoholic beverage, this gradient will start to increase again. And with the increase, a new peak is formed. Because as we said, this peak is dependent on the amount of alcohol that's consumed. So any curve at any different place, depending on the amount of drinks, can vary. And the end is actually the amount of alcohol that's consumed. And that's very important, the height of this curve. And that will be the blood alcohol concentration at that time point. So we looked at the ascending limb as well as the peak. Now let's look at the descending limb of a blood alcohol curve. It's very important that the descending limb of a blood alcohol curve is constant for all individuals. Now this rate is obviously where the rate of absorption is less than the rate of elimination. This constant factor of the descending limb is 0.02 grams per 100 moles. What's important to remember is, irrespective of the amount of alcohol that's consumed and the various peaks, so whether you took one shot and now you're sitting with a descending limb, the constant rate will still be the same. It'll just be eliminated quicker. So if the blood alcohol concentration is higher, it's still only going to be eliminated at a constant rate, which is important to note because you can decide to wait a while, and we'll discuss that later, but it's still only going to be eliminated at a constant rate of 0.2 grams per 100 moles. Let's quickly discuss the Mellanby effect. Now, what was observed by Mellanby was at a similar, let's say 0.1 blood alcohol concentration on the curve. If somebody was in the rising leg of a blood alcohol curve, they would appear more intoxicated than at the same level on the declining limb of the alcohol curve. So as you can see, this guy is looking a little bit more sober and this one is a little bit drunk. So at the same alcohol level on the rising limb, they would appear more intoxicated, or as a matter of fact, appear more symptomatic. So even though we've discussed the rising limb where the absorption of alcohol into the blood is higher than the elimination, theoretically, as soon as the blood alcohol level starts to rise, at that same time point, elimination starts to take place. So this is obviously just for illustrative purposes, but as a matter of fact, obviously the body is a dynamic process, and you can't at this stage say, okay, now it's finished absorbing and now it starts being eliminated, because there's always a diffusion gradient, and this will determine at which level the blood alcohol curve you would find yourself, whether it's going to be the decreasing limb or the declining limb. But already at this stage, the elimination of the blood alcohol would already start, but obviously at a very smaller rate than it would obviously on the declining limb of a blood alcohol curve. And for the most part, remember that the metabolism is related, 95% is metabolized through the liver, where only a small percentage, like 5%, is eliminated through the kidneys and the lungs. So how does the blood alcohol curve relate to, for example, the urine alcohol curve? Both of them have very similar properties in terms of the fluid, amount of fluid that they consist of. Now, if we would look at the urine blood alcohol curve, just the urine curve, not blood alcohol, it will follow an exactly similar pattern. The only difference is that there would be a 30-minute kind of delay between the peak of a blood alcohol curve to the peak of a urine alcohol curve, because that's the time that it would take for the bladder to fill up from the time that it's starting, to go into the bladder from the blood system. So if we look at the relation, for example, to the blood alcohol concentration in relation to the time and elimination, if you sit with a blood alcohol concentration, let's just take 0.02, because we know that's the steady rate of elimination. If at this time point in the peak, it would be 0.02, like whatever, say it's at an hour. This would mean an hour later, at 2-hour time point, that unit of alcohol would be eliminated from the body. However, if the peak of that blood alcohol concentration, because we said that that's related to the amount of alcohol that's consumed, is 0.04 grams per 100 milliliters, that's now the peak, and it's also, let's say, an hour, it would not be entirely eliminated at the 2-hour time point. It would only be eliminated after like 3 hours from the first time of consumption. If we take that at an hour would be a peak, because 2 hours to eliminate a 0.04. Now let's take, for example, a higher peak. Let's say it went to kind of 0.8, theoretically. So to eliminate that, if a peak was here, let's say after 30 minutes, whatever, or let's just say the hour has moved, that would mean it would still only be eliminated at a constant rate, which would be, it would take at least 4 hours for it to be eliminated. So that would only be eliminated out of a system at 5 hours. So for example, now after an hour, you realize, if taken maybe 1 to few drinks, it's now the peak is 0.08. You think, okay, you can wait for an hour. Let's wait for 2 hours. So you're waiting for 2 hours, which is like, say, at this time point. At this stage, at the 2-hour time point, when you start to think to drive, your blood alcohol concentration is still 0.06 grams per 100 milliliters, because it hasn't been, that bit hasn't been eliminated yet. Now you are arrested, and the blood alcohol concentration from the blood is taken. Like let's say hopefully at 3 hours later. So that would be at 0.04 on this curve, because this is eliminated at a steady rate. So let's obviously, unless you've got the person taking the blood alcohol at that roadblock, it will probably only be later. So at this time point, if you take the blood alcohol concentration, now it's almost like 2 hours later, it will only be 0.04, which will be below the legal allowed limit, unless you're a professional driver. But that said, at this time point, you are presuming that it was probably higher at the time point of arrest, and that's where the formulas can actually assist you in a court of law. What's also important in terms of a National Road Traffic Act is there is a presumption that says if at this time point, say you take the blood alcohol concentration, and at this time point, whether it's 2 hours later, is like 0.5 grams per 100 mils, you are presuming that even at the time of arrest, 2 hours earlier, it must have been higher. So it must have been above the legal allowed blood alcohol concentration. It's also important to note that you don't know at that time point when you do take the blood alcohol concentration of an intoxicated individual at which part of a curve they are. So theoretically, or it is actually recommended that you take another blood alcohol concentration 30 minutes after that. So you can see whether that blood alcohol concentration is now higher or lower. And that would also give you an indication of which part of this blood alcohol curve that intoxicated individual finds themselves.